And finally, scientists believe that we may have caught a whisper from another universe, and this is not a sci-fi film, but a real signal that could have slipped through a cosmic wormhole. The big question is...
NASA just dropped a bombshell. A second wave of mysterious signals from the Andromeda Galaxy has hit Earth, and this one's way stronger than the first. It came through at exactly 3:47 a.m. Eastern Time, lighting up radio telescopes across 3 continents at once. The spike was so intense, it fried receiver arrays at the Chime Observatory in Canada for a few seconds. This wasn't static, and it definitely wasn't a system glitch. The spectrogram revealed something wild, a repeating pulse, clear and deliberate. The exact same frequency signature detected 18 months ago, only this time, the signal's intensity is 50 times higher. Andromeda is 2.5 million light-years away, meaning whatever sent this signal did it 2.5 million years ago. Now another burst has arrived, shaking the entire scientific world. NASA's Deep Space Network jumped into action immediately. Within hours, telescopes in New Mexico and Australia confirmed it. The same pattern, the same impossible timing. For the first time since SETI began listening to the stars back in 1960, even AI systems were stumped. The data didn't match any known pulsar, magnetar, or anything in the archives. Now every observatory is asking the same chilling question. If this is wave 2, what's coming next? The first wave arrived 18 months ago, in January 2024. Back then, radio telescopes caught a short, bright flash from Andromeda's direction. Just a few milliseconds of energy. It was bright, sure, but nothing groundbreaking. Astronomers logged it as FRB 240117, just another fast radio burst. But now, that ordinary blip might have been the first message in something huge. Most fast radio bursts come from galaxies billions of light-years away. Distant flashes we barely catch before they vanish. But that first Andromeda burst, it was different, way closer. A single flash, no repeats, no echoes. Scientists chalked it up to a magnetar, a supercharged neutron star having a violent crust shift. Weird, yes, but still explainable. The data got logged, published in a tiny journal note, and everyone moved on. Until now, when the second wave slammed into mission control at NASA's Jet Propulsion Laboratory, everything changed. This wasn't casual curiosity anymore. NASA called an emergency briefing. Within an hour, radio astronomers from CHIME, the Deep Space Network, and the Very Large Array were all patched into a single line. Every major observatory on Earth was listening in because what they saw wasn't a normal repeat. The signal came from the exact same spot in Andromeda, the same coordinates, but its structure, totally different, more organized, more deliberate. NASA's Deep Space Network spun its giant dishes toward the source. The 70-meter Goldstone antenna in California locked on and captured every photon. The signal lasted 3 full seconds, an eternity in radio astronomy. When the data streamed through, every scientist watching froze. This time, it wasn't random noise. It looked intentional. NASA unleashed its newest AI analysis system, the same neural network Google DeepMind once used for protein folding, now retrained to hunt for patterns in deep space data. Within minutes, the AI flagged something jaw-dropping, repeating polarization changes. Here's what that means. Radio waves vibrate in certain directions, like light through polarized sunglasses. Natural sources, pulsars, magnetars, even supernovae, show messy, chaotic polarization. But this signal? It flipped its orientation like clockwork every 200 milliseconds. Perfectly timed flips, back and forth, again and again. No known cosmic event behaves like that. This wasn't random chaos, it was precision. Something or someone was controlling it. But this signal didn't behave like anything natural. It showed perfect order. Dr. Emily Chen at the SETI Institute ran the data through every known model: plasma lensing, quantum vacuum effects, relativistic beaming. Nothing matched. The pattern was too clean, too perfectly timed. Was this a new kind of physics we haven't discovered yet? Or was it something else? Then came the real shock. At 3:51 a.m., just 4 minutes after the signal hit, Earth's own magnetic shield started to tremble. The National Oceanic and Atmospheric Administration's Space Weather Prediction Center picked up a massive spike in Earth's magnetosphere. The planet's protective magnetic field, the invisible barrier that guards us from deadly solar radiation, flickered for 8 full seconds. The disturbance was so strong it showed up across monitoring stations from Alaska to Antarctica. Ground magnetometers caught it instantly, and satellites in geosynchronous orbit logged the impact. The magnetosphere's sun-facing boundary pushed inward by nearly 2,000 kilometers, then suddenly snapped back like a slingshot. NASA's first thought was obvious: a solar flare. The sun constantly blasts charged particles toward Earth, and when a coronal mass ejection hits, it can cause exactly that kind of magnetic shock. But here's the twist. When scientists checked the Solar Dynamics Observatory, the sun was calm. No flares, no plasma bursts, no ejections. The solar wind was completely normal. The sun was silent. For a few tense minutes, every global monitoring station thought we were in the middle of a solar storm. Technicians scrambled to find the source, checking every satellite feed, every ground array, every space weather instrument in orbit. But nothing fit. Something had shaken Earth's magnetic field, and it hadn't come from the sun. Nothing came from the sun, and nothing happened in near-Earth space. It was dead quiet out there. The only electromagnetic event detected in that 4-minute window was the radio burst from Andromeda. And that's terrifying, because it shouldn't even be possible. Radio waves don't affect magnetic fields. They pass straight through like light through glass. A distant signal from another galaxy has no business shaking Earth's magnetosphere. Yet the timing lined up perfectly. The signal hit at 3:47 a.m., and the magnetic disturbance followed at 3:51 a.m., just 4 minutes later, exactly the time it would take for a secondary particle wave traveling near light speed to cross from the upper atmosphere to the magnetopause. NASA's Goddard Space Flight Center went digging through old data, and what they found sent chills through the entire room. They discovered the same signature from 18 months ago, a faint magnetic blip recorded at 4:13 a.m. on January 17, 2024, 8 minutes after the first Andromeda signal. No one had ever linked the two before because it seemed way too small, too impossible. But now, with the second wave hitting harder, the connection couldn't be ignored. That's why NASA jumped into crisis mode. The second Andromeda wave didn't just arrive. It interacted with Earth itself, not through gravity, not through radiation pressure, but through something new, something science can't yet explain. Radio astronomers ran the math, and the numbers were mind-blowing. If the source really came from Andromeda's core, the signal at Earth's surface measured 140 Janskis. For comparison, the brightest fast radio burst ever recorded, FRB 202206110A, only hit 3 Janskis from over 1 billion light-years away. Whatever's out there in Andromeda just sent a signal nearly 50 times stronger than anything humans have ever seen. This new signal wasn't just bright, it was blinding. 50 times brighter, from a source 50 times closer. Apply the inverse square law and the truth hits hard. Brightness increases with the square of proximity. Move twice as close and something looks 4 times brighter. So if it's 50 times closer, that's 2,500 times more intense. The energy needed to pull that off is almost beyond human comprehension. Scientists crunched the numbers and realized the burst released more radio energy in 3 seconds than our sun emits across every wavelength in an entire hour. Picture a flashlight so powerful that if it were shining from the moon, it could outshine the sun for a split second. That's the insane scale we're talking about. Dr. Vikram Patel from MIT's Kavli Institute ran the calculations again and again, 3 times to be sure. He thought his system had glitched, but it hadn't. The data was real, and it didn't make sense. Only 2 known cosmic events can unleash that kind of power: colliding neutron stars and hyperflaring magnetars. Both are extremely rare, both violent beyond words, and both happen once in a single place. Yet here it was, the same location, 2 massive bursts, 18 months apart. The math didn't add up. Magnetars don't have the magnetic energy to fire off a second eruption like that. And neutron star collisions? They can't repeat. They destroy themselves the first time. Whatever unleashed this signal has an energy source that's making every astrophysicist sweat. It's not impossible. But it would mean new physics, something we've never seen before. But here's where it gets even stranger. The brightness wasn't the only red flag. The timing carried hidden information. NASA's AI dug deeper, analyzing the burst's temporal structure, how each pulse arrived, the microgaps between them, and what it found made the whole room go silent. What the AI found made the entire analysis team freeze. The signal wasn't a smooth wave. It was structured, like a coded rhythm. Each pulse lasted exactly 43 milliseconds, followed by 86 milliseconds of silence, then another pulse, then 172 milliseconds of silence. The pattern was unmistakable. Every gap was double the last. 43, 86, 172, a perfect geometric progression. In computer science, that's called exponential spacing, the kind of pattern digital systems use to encode information or organize data packets for error correction. It wasn't random. It was designed. The AI detected 12 distinct clusters of pulses across the 3-second transmission. Each cluster followed the same doubling rhythm, but the number of pulses inside each varied. 3, then 5, then 2, then 7. It looked eerily like some kind of structured message. Dr. Sarah Brennan from Breakthrough. Listen compared the data with known cosmic phenomena. Pulsars rotate and emit precise pulses, sure, but their timing drifts by milliseconds. They tick like clocks, not computers. Magnetar bursts, total chaos. Supernova echoes scatter unpredictably. Even the wildest plasma physics in space produces noise, not mathematical order. Physicists pointed out that nature can create patterns through orbital resonances, quantum interference, or standing waves in magnetic plasma. But this signal was too clean, too deliberate. It didn't sound like nature's messy fingerprints. It felt engineered. Some researchers mentioned a fringe theory called plasma Wakefield acceleration. When charged particles surf electromagnetic waves through ionized gas, they can create rhythmic, harmonic spacing. It's a real documented effect in lab conditions. But to make it happen across intergalactic space, you'd need a particle accelerator the size of a galaxy. Theoretically possible, yes, but never seen in the real universe. So now the question hanging over every observatory is chilling. Is this some unknown cosmic physics, or is it something built? The analysis team pushed harder, running every simulation and natural model imaginable. A few came close, but none matched the precision. That was the key. Nature is messy, and this signal wasn't. Then came the realization that turned curiosity into fear. The second wave wasn't random. It looked like part of a series. Scientists started asking questions nobody wanted to say out loud. If 2 waves arrived 18 months apart, what about wave 3 or wave 4? Could there be a schedule? A team at Princeton University began re-examining Andromeda's core, and what they found added even more mystery. NASA's Fermi telescope has been detecting a strange gamma-ray glow from that region for over a decade, a bright excess of high-energy light that shouldn't exist in those quantities. The top theory blames it on dark matter annihilation, invisible particles colliding and releasing energy. But now, after this second wave, a new possibility is on the table. What if that glow isn't dark matter at all, but something artificial powering up deep inside Andromeda? What if Andromeda's central black hole isn't silent at all? What if it's pulsing like a galactic heartbeat? Supermassive black holes don't shine constantly. They flare up, swallowing gas and stars in unpredictable bursts. Some astronomers now believe Andromeda's 4 million solar mass black hole could be cycling through feeding episodes, each one triggering a massive radio explosion. If that's true, the timing suddenly makes sense. A flare every 18 months could explain everything. Wave 1, Wave 2, and maybe Wave 3 is already on the way. But another camp of researchers has their eyes on something even more extreme: supermagnetars. These are still theoretical, but terrifying if real. Regular magnetars already have magnetic fields so intense they can twist atoms apart. But supermagnetars? They'd bend space-time itself. Standard magnetars are rare but known. Supermagnetars, though, would be the next level. Neutron stars wrapped in unimaginable magnetic power. They could experience magnetic reconnection storms like solar flares, but a trillion times stronger. Imagine that. Waves of magnetic energy building up, snapping, then rebuilding again in endless cycles. It's the kind of cosmic storm that could easily explain the repeating radio bursts. The math behind it? It almost works. But it demands the magnetar to have a layered, exotic interior made of superconducting materials and neutron superfluids. Physics that pushes the edge of what quantum mechanics even allows. Now, nobody's jumping to call it artificial. The official stance still leans toward natural causes. But the precision of these bursts is making some experts uneasy. Dr. Avi Loeb from Harvard dropped a key observation. When nature shows order, it usually comes from something simple. Crystals form neat patterns because of atomic bonds. Planets orbit in perfect math because of gravity. But when order appears without a clear physical cause, we've crossed into unknown territory, not impossible, just unexplained. For the first time in this entire investigation, it didn't feel like we were just listening to random static. It felt like someone knocking on the door. Let's slow down and lock in what we actually know. Andromeda is our closest galactic neighbor, sitting 2.5 million light-years away from Earth. That number matters, because when we look at Andromeda, we're not seeing it as it is now, but as it was 2.5 million years ago. Light and radio waves travel at about 300,000 kilometers per second, and nothing in the universe moves faster. So when these signals reach us, we're literally peering into the past. That means whatever created these bursts happened 2.5 million years ago, when early humans were just figuring out how to use stone tools. Those signals have been racing through the empty void of space all this time, only now reaching our telescopes. Think of it like thunder and lightning. You see the flash first, then hear the thunder later. But in this case, the storm is ancient. By the time we're hearing it, entire worlds could have risen and disappeared. Civilizations could have come and gone in the time it took for these radio waves to travel here. That's why the second wave is such a huge deal. If both signals really came from the same spot in Andromeda, that means the source was active, producing multiple bursts separated from our point of view by 18 months. But here's the twist. Those 18 months only exist in our time frame. From the source's perspective, both signals might have happened just hours or days apart. We're just seeing them on a massive cosmic delay, stretched out by the unimaginable distance between galaxies. Fast radio bursts, or FRBS, are a known phenomenon. CHIME detects them all the time. They're super short flashes of radio energy, just milliseconds long, coming from galaxies far away. But here's the catch. Most of them happen once and never repeat. Andromeda's? It did it twice. And counting. Some fast radio bursts do repeat, like FRB 201-21102A, which is fired off hundreds of times. The leading theory? Magnetars, neutron stars with magnetic fields a quadrillion times stronger than Earth's. When their crusts crack under that insane magnetic pressure, they unleash colossal explosions of energy across the cosmos. Then there are gamma-ray bursts, even more powerful, unleashed when massive stars collapse or when neutron stars smash into each other. These are the brightest electromagnetic events in the entire universe. Just to grasp the scale, a single gamma-ray burst can release more energy in 10 seconds than our sun will emit in its entire 10 billion-year lifespan. That's pure cosmic fury. Both fast radio bursts and gamma-ray bursts are real, documented, and constantly monitored by observatories worldwide. They're wild, yes, but they follow the rules of physics. Extreme conditions, but still natural ones. The question now is whether Andromeda's mysterious signal fits those boxes, or if it's something else entirely, something we haven't even named yet. Here's what we know for sure. A second wave from Andromeda has been officially confirmed. Multiple observatories, independent verification. The signal is real, and right after it hit Earth, our magnetosphere flickered, a measurable pulse in the planet's own magnetic shield. No solar flares, no cosmic rays, no nearby interference, just that eerie timing that has scientists sweating. And then there's the intensity, 50 times brighter than the most powerful fast radio burst ever recorded. The kind of energy that stretches the limits of known astrophysics. But the weirdest part? The structure. Those perfectly spaced pulses, doubling intervals, and binary-like rhythms that NASA's AI flagged. The data shows something too clean, too intentional to be random noise. It's not confirmed as artificial, but it's not comfortably natural either. Whatever's coming from Andromeda, it's playing by rules we don't understand yet. NASA's emergency briefing didn't jump straight to the aliens word. Scientists know better than to make that kind of claim without extraordinary proof. But what they did confirm sent chills through everyone watching. Something powerful, and maybe even intelligent, just sent a second message across galaxies, and it reached us. Right now, no one's calling it contact, but they all agree, whatever this is, it's real. And it's huge. Whether this is nature showing us physics we've never imagined, or something more deliberate, the truth is equally shocking. If it's natural, we're witnessing forces that could rewrite physics itself. Exotic matter, quantum-scale phenomena, energy far beyond anything humanity has ever created or even dreamed of. But if it's not natural, then something in Andromeda, 2.5 million years ago, had the technology to beam a signal across intergalactic space, strong enough to reach Earth and structured enough to make sure we'd notice. Either way, Andromeda isn't just a pretty swirl in the night sky anymore. It's a mystery, one that's staring right back at us. Is this nature at its most extreme? Or the first hint we're not alone? One thing's for sure, Andromeda has our full attention now. And if there's a third wave coming, we'll be ready. Every telescope, every AI system, every deep space monitor on Earth is locked on that part of the sky, waiting for the next pulse. So don't miss a second of what's coming. Subscribe, like, and share this video, and hit that notification bell so you're the first to know when Wave 3 arrives. Because whatever comes next, you'll want to see it as it happens. The universe just knocked, and for the first time in human history, we heard it loud and clear.